Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Welcome to the SEI Podcast Series. My name is Tim Chick. I'm the Technical Manager of the Applied Systems Group here at the SEI. I'm pleased to introduce to you two of my colleagues, Sasank, Vishnubhatla, and Maxwell, Trdina. Welcome. So we always start our podcast series, kind of tell us a little bit about yourselves. We'll kind of go alphabetical. So Max, we'll start with you. Can you tell us why you came to the SEI and some of your interests?
Yeah, so I have been at the SEI now for about a year and a half. Before this, I was working more in the manufacturing sphere, doing quality control software. And I think what brought me to the SEI is just I liked the SEI's focus on security as well as DevOps best practices, not only doing them, but also, advancing the state of where they are, and also how to make that accessible to other people and how to make it easy for other people to implement themselves.
Right. So, one key that what I love about being here, right, is that applied research aspect, right? You get to do new things, you get to try different aspects, but then it's not fundamental research where I'm trying to boil the ocean. It's applied research where I work with customers and really get to help them solve their hard problems, right?
Yeah.
Which I think is also kind of what led to this blog that we're going to talk about.
Yeah,
right?
Definitely.
Is the experience you've had with various customers.
Mm-hmm.
Sasank, can you tell us a little bit about yourself and what brought you here?
Yeah, so like Max, I'm also a software engineer here. A little greener. I came here about just a little over a year ago. I've got some experience being a systems engineer and also doing some software development in the government contracting sphere. So was familiar with the SEI prior to actually working here. And as a CMU alumni, it's nice to kind of be back in a very familiar environment. One of the big things that you touched on that SEI does is a lot of applied research, specifically in the cybersecurity field. And that's been something I've been doing since I was in high school, doing research in cryptography back then and kind of continuing that in college. So being able to do that here with the work that I work on, some rapid prototyping and MBSC work that we do, being able to continue that research is something that I'm really excited and really glad to do here at SEI.
Great. So today we're here to talk about Docker containers and kind of the vulnerabilities and the issues that are around them. So for those people that are earlier in their careers, right, this kind of an introduction to these concepts, why would someone use a Docker container? What's this major use case? What are some of the vulnerability?
I can take that first here. Yeah. So this is something that I definitely am interested to talk about because this is not something I'm sure, I don't know if you had this experience or not, but when I was in college, we didn't talk about containerization. We didn't talk about Docker, didn't have any sort of figure this out, do this for yourself. It was entirely new to me.
It wasn't that long ago.
Yeah. Well, yeah, it was something that, I sort of learned as I went along. And even in my first job out of college and whatnot, we were doing things like running monolithic applications, more or less everything all baked into one big program. And so it was not something
concept of microservice.
The microservices were not really a concept that was really something I was familiar with until actually somewhat recently. And I think that once I actually was exposed to it and learned about it, and then I realized how much of the world actually operates that way and how pervasive it actually is, that was pretty neat. And I think it's definitely worthwhile to talk about that. I don't know, maybe someone else has the same experience. But containers are really neat. They allow you to run individual applications in a very isolated, very controlled, very repeatable way that you don't get if you just run them on your system. And that gives you a lot of advantages. For example, say you're, hosting, let's say, a website, and you have, your web server service, and you maybe have some backend services like a SQL database and what have you. What else? It doesn't, the list is endless. If you were deploying this the old school way, you would install them all on the same machine, probably, maybe not. But they would have all sorts of dependencies that would have to be resolved. Sometimes they might have conflicting dependencies. How do you fix that? Docker solves all those problems by just giving everything its own little area where it can run the things it needs and nothing else, and only talk to things, as needed over a specialized network it creates. And so it solves a lot of those older monolithic program problems.
So people old like me, right? What you experience really traditionally would be, someone would come back and say it doesn't work, or there's this defect, this bug, and I go, well, it works on my machine, or it works in my staging environment, right? You had this disparity between environment.
Yeah.
Right? And I think Docker
exactly,
and the whole imaging construct really eliminates that.
Yeah. Not only do you get the benefit of not installing it on your machine, but you actually get an identical machine, or you get an identical environment every time. And so you can hand them out to anyone and they will work every time, which is
that's a huge plus, I think, is the fact that it's easy distributability. You can hand it out to everyone, like you said, and everyone is able to actually say, yes, this is the same copy. We all have the same, versions of these containers that we're running, and we all should expect the same behavior then. And this type of paradigm is huge for large cloud computing companies, for cloud services. You think of your favorite online web hosting service, your favorite document editors online. All of these services, these are all really just some sort of application running in a Docker container on some sort of server somewhere. That is a lot of isolation away from another type of service that could interact with it. They could have these interactions, but by isolating them, you're able to monitor them better. You're able to see, is everything working properly? You're not mixing lanes and getting potentially confused. This also allows you to, in isolation, track vulnerabilities. You're able to look at a snapshot of your service running and say, okay, I want to look at this picture almost and look and see, are there any defects? Is there anything wrong in that moment? That lets you get a vulnerability scan in the moment, which is huge for assessing the security of your system. Containerization, the fact that it isolates away your running services and a lot of things from your actual system, which you, the user, might be changing, that allows for a lot of replication and replicatability across young developers who are able to say, okay, I can remove a lot of these potential red herrings in my development and just focus on this I know is to be true, so I can work on it then.
Right. So there's two things there, right? One is the scalability, right? And so one cool thing, traditional, virtual machines or even hardware, right? You have to have dedicated memory, dedicated, CPUs, right? Where this allows you to scale that up and scale that down and actually maximize the use of your CPUs and your hardware, right? Or even minimize your costs in the cloud, right? You don't have to over provision your containers, right? So when you're paying, per CPU, or you're paying based on the amount of memory you use, right? There's huge cost savings even in the cloud environment as well.
Yeah,
right?
And applications like Docker that allow you to spin up these containers and build them from base definitions or recipes, like from Docker files, for example. The fact that you can control kind of the data flow and say, I only want on this Docker network data to flow this fast. That is a cost saving methodology that a lot of people and a lot of developers will use to ensure that, like you said, your environment, your platform is scalable in that sense. And I think you have some experience actually working a little bit with scalability of this.
Yeah. And I was going to add on to that. Yeah. You throw in something like Kubernetes into the mix here, and suddenly you give yourself a lot of control over resource management and fault tolerance and things like that. And it's just a little bit outside the scope of our discussion here, but it's just additional icing on top of the cake.
Yeah, but I think it's important as an introductory, right?
Mm-hmm.
So we kind of hit like the economics, and then from the technical, why it benefits the developer. It makes your life easier. You don't have to focus on everything. You just focus on the resources your application needs to run effectively, right? From an engineering perspective, it simplifies your area of concern, right? But with that said, right, with the economics being there and the engineering, areas of concern being there, the next step is security, which is what our topic is, right?
Mhm.
And so what have you seen that really has made you question or really become concerned about the security practices of building and sustaining these containers?
So I mean, on one hand, Docker as an entire entity, as a piece of software, can also have its own vulnerabilities. We're not really focused on that aspect of it, but I just figured it would be, worth mentioning that, this stuff is everywhere. But
Docker is just software. Like
yeah,
everything
it's just
else.
like anything else. Yeah.
Exactly.
But what we're really more focused on is, you pull an image off of Docker Hub. You say I need, in my example earlier, you need my Nginx server and you need, MySQL or something like that, Redis, for example, I don't know, whatever you may need. When you have containers like that, you can generally reasonably assume that they're probably pretty secure right off the bat. It's not a terrible assumption to make. But sometimes you're curious, or sometimes say maybe you're pulling a container that's maybe a little bit smaller, maybe a little bit less common, a little bit less used, maybe a little bit more specialized for your application. And, now you're more beholden to the decisions that individual software developers have made in the process of not only developing the application that you're using, but also how did they make it into a container image that you can then deploy. Both of those things are areas where vulnerabilities can be introduced.
Right?
And-
But even when you take a trusted source,
Mhm.
it's really trust but verify.
Yeah.
Yes.
Right? You shouldn't just blindly trust because they say they have this process and they're providing secure, Docker images, right?
Mhm.
Because the reality is you're the one assuming the risk.
Yeah.
Right? As an organization or as a company or even as an individual, if you spin it up to run your application,
Mhm.
right? It's really buyer beware, right? The burden's on you. It's not on the person who produced that container and made it available to you.
Mhm. Yeah.
Exactly. And so part of and what Max was talking about, kind of looking at whenever you go to like an open source developer, some individual who's providing you some specialized piece of software, and maybe they do provide you some Docker file or an image that you can pull, as kind of you said, sure, you could trust that they've provided you secure software, but it's on you, the developer, to ensure that. And the ways that you can do that, which we talk about in our blog post, there are a couple of good ways we can do that. First being starting with a kind of a benchmark scan using tools by Anchor like Gripe or Trivy, which is published by Aqua Security. These are two really well-known tools in the community, in the security community, that allow you to create vulnerability scans and digests from a Docker image or even a Docker file or even a running container, for
So I'm
example.
assuming when you say that, you're meaning it scans it and it says, okay, you're using this library or this application or
Yeah.
this software, and here's based on the versions you're running, there's these CVEs.
Yes, these CVEs or these vulnerability, I think CVE, the acronym, what it stands for is blanking on my head, but what a CVE, what it tells you is the information about a vulnerability, when it was found, if there's any bug fixes, the affected versions. It's a great identifier for the vulnerability. What these scans will do is help you identify what vulnerabilities exist in that image. And this is beyond just the code of the software you're using in the image. This is also the information about the operating system that the image provides. Docker images are very similar to virtual machines, but they operate in a much more slimmer, sleeker, faster context. The way I kind of like to think about it is your virtual machine almost virtualizes your full computer architecture. Well, your Docker container, whenever it executes, it doesn't need to virtualize the entire computer architecture. It's only a small part of it, so it can actually be much more lightweight and therefore scalable. There's still parts of the OS that are required, which a container image will provide. And that's where a lot of vulnerabilities can actually be seen. I think you actually can speak to one in particular that is pretty bad, vulnerability in Docker containers.
Yeah, I was just looking into this recently, and apparently there was a CV in 2019 where an attacker could overwrite a run-C file and therefore break out of a container on a machine. And that's just one example. I mean, that's
to basically break out of the container.
Break out of the container.
Now they're on the underlying system, either virtual machine
in a greater context. Yes, yeah. Mm-hmm.
And so to think about, what exactly, let's just make a little fictitious scenario where this could come in. Let's just say I'm providing software to a customer and I have this vulnerability. Some third party could gain access to my system then through my container, which is exposed to the web. I'm running some web service. Through that connection, be able to gain full privileged access to my host system that is hosting all of my services, that probably has connections to all my databases, that has potential user information, that has all the credentials of the host system, which is running these services. That is a huge potential data breach. And so locking down the not only Docker, the software, but the container, the actual container software that's running, doing your due diligence on the Docker file is going to be huge, and that's part of hardening your image as well, which I think.
So one example I think you say in your blog is manage the privileges of your container.
Yes.
Right. So if you're running a Linux, you don't give them root access.
Yeah. Don't execute whenever you're running the Docker container, don't run as root. One of the biggest kind of mantras in the cybersecurity field is the idea of least privilege. If your Docker container doesn't need to run in root, then don't. It's as simple as that. There's not a need for it to be able to access everything. Don't give it access. Only give it access to what it needs. It's kind of like a child almost. Whenever you have a baby or you have a small child, you baby-proof your house. Well, your operating system, your host system, that's your house. These services are the babies in this case. You got to baby-proof your house. Make sure the baby can't accidentally get a knife and hurt something.
So Max, based on what Sasank says, is there another technique beyond like the root admin privilege aspect?
Yeah, like what Sasank said, specifying a service user is a great thing to do, because you then can prevent unauthorized access, even if someone does break into your container.
Or breaks out of your container.
Yeah. But alongside of that, there are other things you can do in your Docker file that can also add additional, or not add additional security, but prevent other types of exploits. For example, an easy one, and Docker will tell you this on their website too, is that you don't really want to use the add instruction anytime you can avoid it, and instead just use a copy instruction. They have very similar functionality in that you could both use them to move a file from here to over here in your local build environment. But the add instruction can also, it can do things like it can download a file from the internet. You can just give it a URL, it'll download it. You can also use it to unpack like a tarball. Like if you have some unknown tar archive file that you need unpacked, it'll do that for you too. And those are not inherently bad things, but they are certainly exploitable. Say you need to download some sort of artifact from somebody's GitHub page, and say you're getting that from a variable defined somewhere in an environment file, and say that gets changed, maybe in someone's automated build process somehow that gets modified, and now you can use that as an entry point to insert whatever you'd like. And so
right, if someone understands that about your architecture, they can go, okay, well, I can't attack you directly, but I can attack this thing that you're copying into, or you're adding into your system.
Yeah.
Right, from some maybe not as trusted source.
Yeah.
Right.
Another thing that's maybe a little bit on the qualitative side is just look at what base images your container is using. Say if you're especially in the case where maybe you're adapting an existing Docker file, say, hey, this project makes it, or like builds a Docker image, or I found this GitHub repo that builds a container image based on some open source project that I'm using, or something like that. You want to look at their homework. You want to see, what are they doing? What are their base images? If your goal is to harden their product, you say, hey, that base image, I've never heard of that before, or I go and see where it comes from, and well, maybe it doesn't really get maintained that frequently, or something like that. You want to make sure that you're substituting that kind of stuff out wherever you can.
Okay.
For if you can, if your base image is just an operating system, say you're using Alma Linux or something like that. If they're using something else that's maybe a little bit less common or less supported, then maybe you consider switching that out for something a little bit more
mainstream,
something that has a security posture, something that just is more secure.
Right. So we're going to talk about security, right? And we've kind of dove right into some techniques one could use, right? So I kind of want to just take a step back, a little bit more abstract, and say, okay, if I want to set up a secure container, right? I'm an engineer, I'm a developer, and this is what I've been asked to do. Kind of what's that process that we want you to go about doing that? I kind of also take a step back. We're also throwing out some terms, right? So it's
Sure.
kind of introductory, right? Can you start to kind of explain what a Docker file, an image, and a container are, what their differences are, and then lead that into the security concerns as we walk through them?
Yeah, definitely. And I can start us off here. So you actually described the order perfectly of Docker file into image into container. And I kind of like to think about this as almost like as an evolution standpoint. So you have your very first source, which is your Docker file. This is the recipe. This is grandma's instructions for how you got to cook your image. And that cooking is your base image, what you want it to come from, whether it's going to be your batter, whether it's going to be a piece of bread, whatever you want it to be, that is your base OS, the base of it. Then you have all of the instructions that brings in your source code of the software you want to execute inside of it. As Max had told us earlier, not using add or trying to remove it as much as possible, instead using copy, which is much more directive in nature. And all of that happens in the Docker file, which, as I like to think of it, is the recipe for the image. The image is the defined kind of, it's the whole meal, but you're not eating it yet. You're not allowed to do anything with it yet. It's just kind of there.
Pretty to look at.
It's pretty to look at. It's ready. This is what you can distribute to everybody. So kind of a funny way of thinking about it. If you know how to make a cheeseburger, this is your cheeseburger wrapped up in a wrapping that you could go sell. So this would be the start of McDonald's in essence. Now, whenever you get your meal, whenever you get your burger and you're about to eat it, you have become the container now for the meal. And that is exactly what a container is. You're actually using it. You're using the service that the meal has provided you, eating that wonderful burger that you got. And so from a Docker file, this is what you develop, your source code. Most developers will be looking at this initially and saying, this defines to me the step process that my container will be going through and actively running. The image is the middle ground that says, here is the step-by-step process separated into layers of what I'm going to do. You have security scanning software like Gripe and Trivy previously mentioned that are able to do analysis on all three of these states. The source state, the Docker file, look at it and say, your base image has this many vulnerabilities. If you're using this piece of software, understand it has this vulnerability. Looking at your image, these pieces of software can scan through each layer and help you create a vulnerability digest. And so this would be what you would create as your baseline for your software from a security standpoint. Whenever you've created your image using Docker, you've built your image, you would get a security a vulnerability digest of that image. And that's what you'd say is, here's all the vulnerabilities I have. I'm done developing. I've now built something that could be usable. I want to see how usable and vulnerable it is. In actual, in implementation, whenever something is running, you can take a real-time snapshot of the container and do vulnerability analysis of that. So that is a repeatable process that you want to implement.
Is really, like there's static and there's dynamic testing, right? So container, since it's instantiated, is actually running, right? That would be a dynamic.
Correct.
Right, and the other two would be more static.
Yes, exactly.
Right? I think the other part is from a cybersecurity perspective to think about, for audiences, is that the most knowledge you will have will be the Docker file.
Yes.
Because it's the most prescriptive. The recipe gives you all the details of what makes it up.
It's a ground source of truth, which you want to be able to base all of your security scans and all of your knowledge from. Once you have if you're going to be using an open source container, what you should try to do, and what's highly recommended, is if you're going to be using a running container, find its image definition or its Docker file. Do your homework, study that, ensure it is not going to have, insecure software loaded. It's not using add, as Max has said. And then when you look at the image, you can look and see, is the image executed without, in the proper format? Are we giving it a service user, or are we accidentally executing it, giving it root privileges? At each point in this process, you can look and say, there's a security mindfulness task I can look at and say, am I doing my due diligence on my Docker file? Am I executing my image in the proper conditions? Whenever I'm looking at my running container, my security mindfulness task there is getting a security scan, is actually running a live scan and saying, how am I looking in real time? And feeding that back, all that information back to my development, to my Docker file, and saying, back in the Docker file, in the running environment, I have these problems. Let's address them in our development environment and keep this process iterating so that we can drive down the amount of vulnerabilities that exist in your code base.
So Max, based on what Sasank said in terms of the overall process, is there any step that you think is key to success in really ensuring the security, or gotchas that one should try to avoid?
I think that, on one hand, I also just want to say, I don't want to make it sound like thou shalt not use the add instruction. It will never be used ever. There are definitely good use cases for that. Just wanted to sort of say that. But also, so I guess to answer your question about a most important step, I don't think that there's necessarily a most important step. I think it's just and this could dive off into a discussion about just best practices at large, which maybe is a little bit too much, but it's just a matter of just doing it's just a matter of applying best practices. You can there are many things that are beneficial from a security perspective that are also beneficial for other reasons, like size. For example, if you're building a container image, if you need to build, if you need to use GCC to make a bunch of code that will run and perform some task for your ultimate end goal, end piece of end container, end service, end piece of software, maybe you don't need make in your final image. And so one of the things you can do is you can use, multi-step build processes where you specify in my Docker file, hey, first we're going to make this, and we're going to get some result from that perhaps. And then you're going to take some of that result and use it somewhere else, I guess.
So based on your example, right? So I need to run a C compiler,
mm-hmm.
right? So
yeah.
I run my compiler. So
mm-hmm.
I copy in my compiler,
mm-hmm.
run it, build my executable,
mm-hmm.
but then I delete that compiler.
Yeah, well, so what you can do is you don't have to delete it. What you can just do is you can say, hey, I've taken the result from my compiler, my compiled code, and you can just use the copy instruction to copy that, and you can put it in a later build stage. So that way you can take your built code that will do the task you need it to do without taking any of the dependencies required to actually get it to the point that it's at now, which if they have no relevance to your end product, they shouldn't be there, because it's just added size, added space, maybe not that much, but it's everything adds up. And also, it's just another vector for vulnerability at the end of the day. If you find out that, this version of this Python script, this Python function I used, has some issue with it or something like that, or is abusable, and you don't need it for your end product, then it shouldn't be there. And you can use multi-step build process or multi-stage build process.
So just a fundamental cybersecurity perspective, right? You're minimizing your attack surface,
mm-hmm. Yep,
right, or the vectors of attack. Right?
Yeah.
So that's a key to minimize your cyber risk
mm-hmm.
technique. And I think you were kind down there's things that are just good engineering practices.
Yeah,
that's just one of them. And it applies to Docker containers.
Mm-hmm. Yeah, and it also applies from a security perspective as well as just a best practice for size or something like that. I was sitting here trying to think of how I could bake this into the food analogy. There's definitely something there, but I don't have it. I don't have it in me at the moment.
Yeah.
But
not everything has to be an analogy,
yeah.
right?
But what you're saying, Max, I think is extraordinarily true of kind of Dockerized solutions or containerized solutions, is engineering best practices that you would use in your more waterfall products. These products that do not require this microservice architecture, those best practices still apply. Your projects are now microservices and things are just now at a smaller scale, but you should still do those best practices. And that's something that what like containers allow you to do is you're doing it at a smaller scale now, but it's still incredibly important.
Right. So kind of what I'm hearing is just that, Docker file, image, container. I really should never just download a container off the internet and use it.
Correct.
Right. Because even if I run some tools, there's some, what the tools can look into that insight is limited compared to the more detailed script and recipes that one can use. Right.
Well, and this is actually a good segue to talking just about, what types of things, like what are the pitfalls, what are the risks, what are the can you do it wrong? And I think from the perspective, should I never pull an image I haven't vetted? Should I never do that? No. I mean, the thing is, at the end of the day, we all do it. I say I need something, I'm going to just pull it from Docker Hub, and it would be an over application of it would be a bit of an over application of caution to never lock everything down as much as possible. And I think it's also important to always talk about how security is a balance between usability and security. And if you build a house with no doors in it, you can't break in, but also you got no doors. You
can't get out.
Yeah, you can't get in or out. So
it's not a really usable house then. And you're absolutely right. You can over harden something in a sense where your software is no longer usable. Whatever you're trying to do inside of your container, you've locked down the container that nothing can get out and nothing can get in. So your software in essence is running in pure isolation. If that's not your end goal, but you accidentally got there, well, that's okay. You've just made a couple over-hardening steps in your process. And so going back, and I like to think these things through kind of like a requirements process. Each iteration you go in your hardening process, you're refining and redefining your hardening requirements of all the CVEs I need to remove. But if you over-define them, if you kind of, say I need to remove all of these things, I need to make sure it's so secure and overgeneralize your security, you get a house with no doors. Right. And unfortunately can't use it.
That really comes down to your risk posture.
Yes.
Or aperture, right? And so it's well, what's the use case of this application or this container, right? And then based on that use case and severity of the ramifications, if someone were to break into it or it become unstable or someone were to be able to manipulate it, right? Or violate it in some way, right? What's the implications? What's the risk that I'm exposing myself to? And you need to balance that, right? I would expect someone, who's building a container for, especially in the cyber physical world, that might actually be able to do physical harm to someone, right? Hardening is much more. I'm going to lock it down farther, or I'm going to do a layered approach and put other controls in place to make sure it's secure, that it only does what it's supposed to do. It can cause no harm. Right?
Yeah. And those types of solutions actually do exist. Kind of thinking about it from like a watchdog perspective, where you could have a container service that is trusted and verified in that container service, that its entire job is to monitor the other running services. And so you have these different ways of monitoring your attack vectors and saying, okay, I have to have a container running. It has to be working. Do I have something that can monitor it and say, okay, only this network traffic can go in, or only this system traffic can go in, or it can only do these certain operations, and it works in a locked down type of manner. All of these are types of hardening approaches. Just depends on, as you said, your security approach or your risk approach, and then also the defined needs of what the hardened container needs to do. If it can be relatively open and just needs to lock down communication, that can be done, through the Docker file. If it needs to have specific OS level security things, that is done through your base images and ensuring that whatever you're building your service on top of from a Docker perspective or from an image perspective that your underlying dependencies are secure. And as kind of Max had said, if some of them aren't secure, that's okay if you have to use them. Do your due diligence, work around that. And then also, there's nothing wrong with you giving back to the open source community and working on it yourself and saying, I'm going to help create a hardened version of this used tool. Let's just say you use a really nice tool that's out there, but it's really insecure. There's nothing wrong with you yourself going and supporting open source development and providing a secured version back, a hardened image of that software running back to the community. You're not only providing value for yourself if you're going to use it, but you're helping others improve their security posture and overall increasing the general security of the population, cybersecurity of the population. That is a net benefit, I believe, that we should be mindful of as well.
Right, which is the whole purpose of the open source community, right?
Exactly.
The many contributing to the betterment of mankind, right? Because open source people are just volunteering their time in a lot of instances, right? So what's next? So we kind of talked about this, applied research, SEI, things that excite you. What can we look for and see in a future podcast?
Yeah, do you want to kick off some stuff?
Yeah, so I'm currently working on a different project where I'm working on deploying hardened container images in a Kubernetes cluster. I'm actually using them to stand up services and whatnot. And so it seems like it would perhaps be the logical next step. Not only going from making hardened container images to actually using them for something. So that's something I'm working on, and I'm sure I'll have commentary and things to share about that.
Great, look forward to it. Sasank?
Yeah. So kind of looking at the benefits of using hardened Docker images, and some work I'm doing is changing the environment of how you use these hardened images. So having them run in an air-gapped environment, and then also looking at building these hardened images and running these hardened containers in automated settings so that you don't have, if you have easily mitigatable vulnerabilities that can be automatically mitigated, actually doing that in a CI/CD pipeline or continuous integration, continuous development or deployment pipeline, since that gets more secured software to the end user faster. You're able to get that at an iterative pace instead of at a much longer per release pace. So looking at ways to speed up getting hardened images out there for people.
Great. I look forward to it. Sounds very interesting. So thank you for taking the time to speak with us today. For those out on the podcast, we will include in our transcripts, we'll provide links to any of the material that we talked about today. We will also remember that podcasts are available in SoundCloud, Spotify, Apple Podcast, as well as a YouTube channel. So thank you for joining us, and I look forward to a future podcast.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, TuneIn Radio, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.